Hello children, how are you? Welcome to mathematics class for class 10. Today we are going to do chapter 7, coordinate geometry. Children, you have done a similar chapter in class 9, haven't you? Coordinate geometry again? Yes. In that chapter we studied how to locate a point with the help of coordinate axes. Now what are we going to do in this chapter? We are going to do some new things. We are going to find distance between two such points. We are going to find the area of the triangle formed by three such points. And we are also going to find the coordinates of a point which divide a line segment in a given ratio. Before doing all this, let us look at this example. Seema is an interior designer who is given a task to design a room in a boutique. The room is rectangular in shape, as you can see. To make the designs, she makes use of coordinate geometry. With the help of chalk, she marks one corner of the room as 0, 0 and equal marks along x-axis as 1, 2, 3, 4, 5, 6, 7, 8 and similarly along y-axis 1, 2, 3, 4, 5, 6, 7, 8, 9. So, the length and breadth of the room are acting as positive coordinate axes. That is, this is positive x-axis and this is positive y-axis. Now, isn't it easy for her to explain to the workers how to design the room, even if she is not on the site? Let us see how. She has instructed her workers that two stools will be placed at point 2, 5 and 5, 5. Do you remember when we say 2, 5? 2 is the x coordinate or abscissa, that is distance of a point from y-axis. And 5 is the y coordinate or ordinate, that is distance of a point from x-axis. So in this way, the first stool will be placed here and second here. Seema wants to know what is the distance between points A, where she wants to keep a lamp, and point B, where she plans to keep a mirror. Let us help her by using coordinate geometry. Clearly, AOB is a right-angled triangle. So, we can use Pythagoras property here. AB is the distance between points A and B. OA is equal to 2 units. OB is equal to 3 units. So, AB is equal to under root OA square plus OB square. That is under root 2 square plus 3 square or under root 4 plus 9, which comes out to be under root 13 units. So, what if she wants to find distance between first stool at 2, 5 and right front edge of sofa at 6, 8. For this, let us try to find distance between any two points P and Q having coordinates x1, y1 and x2, y2. Then we will apply it specifically for these 2 points. Children, we will first draw PR and QS perpendicular to the x-axis. A perpendicular from the point P on QS is drawn to meet at the point T. So, in this case, OR is equal to x1, OS is equal to x2. So, RS will be x2 minus x1, which will be same as PT. Also, SQ is equal to y2, ST is equal to PR is equal to y1. So, QT will be equal to y2 minus y1. Now, we will apply Pythagoras theorem in triangle PTQ. So, PQ square is equal to PT square plus QT square, which gives us x2 minus x1 square plus y2 minus y1 square. So, PQ will be under root x2 minus x1 square plus y2 minus y1 square. Since distance is always non-negative, we take only positive square root. So, the distance between 2 points Px1, y1 and Qx2, y2 is equal to under root x2 minus x1 square plus y2 minus y1 square. Children, this is called the distance formula. In particular, the distance of a point pxy from the origin O, 0, 0 is given by OP is equal to under root x square plus y square. Children, can we write PQ as under root x1 minus x2 square plus y1 minus y2 square? Is it possible? Yes. You know that even if we exchange the position of x1 and x2, we may get a negative number sometimes, but on squaring, ultimately we are going to get a positive number only. So the answer will remain the same. That's why these two formulas are correct. So what will be the distance between 2 points 2, 5 and 6, 8? Distance will be equal to under root x1 minus x2 square plus y1 minus y2 square. That is under root 2 minus 6 square plus 5 minus 8 square, which can be written as under root minus 4 square plus minus 3 square. That is under root 16 plus 9 under root 25. And what is square root of 25? It is 5. So the answer is 5 units. So children, this is how coordinate geometry can be applied in real life situations around us. Now let us do a question which is an application of this distance formula. We have to check whether points A, 3, 1, B, 6, 4 and C, 8, 6 are collinear or not. That is, we have to find whether they all lie on the same line. Now children, if 3 points are lying on the same line, certainly the distance between first 2 points, distance between second 2 points, when added up should give distance between the first and last points. But we cannot say which will be the point here. Here it will be A, or here it will be A, or A can be here. This we cannot say certainly. So what will we do? We will just find the distances between any 2 points. First we can find distance between A and B. So AB will be equal to under root. Now our formula is x1 minus x2 square. A point has coordinates 3, 1. B point has coordinates 6, 4. So for this case, which are the x coordinates? 3 and 6. Let us find difference between them. Square the difference plus now the difference between the y coordinates. Now let us solve it. 3 minus 6 minus 3 square plus minus 3 square. This gives us 9 plus 9 under root 18. Now if you factorize 18, you get it is equal to 2 into 3 into 3. So this is 3 root 2 units. So we get AB is equal to 3 root 2 units. Now I'll find the distance between the next 2 points. BC. B has coordinates 6, 4. C has coordinates 8, 6. So this is equal to under root of 6 minus 8 square plus 4 minus 6 square. So we get minus 2 square plus minus 2 square. That is under root 4 plus 4 under root 8. Now 8 has factors 2 into 2 into 2. So we get 2 root 2 units. So 2 distances we have found. One is 3 root 2, another is 2 root 2. Now let us find the third distance, AC. A has coordinates 3, 1. C has coordinates 8, 6. So AC will be difference between A and C, 3 minus 8 square plus 1 minus 6 square. So we get minus 5 square plus minus 5 square. What is minus 5 square? It is 25. 25 plus 25, it gives 50. 50 has factors 2 into 5 into 5. So this is 5 root 2 units. Now we have found 3 lengths, AB, BC and AC. AB is 3 root 2, BC is 2 root 2 and AC is 5 root 2. Is it possible that sum of 2 lengths is equal to the third length? Yes, we can see that AB plus BC is equal to 3 root 2 plus 2 root 2, which is equal to AC equal to 5 root 2. Sum of two lengths is coming out to be equal to the third length. So we can say that if A is here, B is here, C should be here. AB, that is 3 root 2 plus BC 2 root 2 is equal to AC. So clearly these 3 points are collinear. That is, they lie on a straight line. So this is how we use distance formula to reach such conclusions. Now let us do another question. Find a relation between x and y such that the point xy is equidistant from the points 3, 6 and minus 3, 4. So here we are talking about 3 points. One is xy and we have other 2 points 3, 6 and minus 3, 4. We are given that xy is equidistant from these 2 points. Let us name these points as A, B and C. So we are given that if I write this A as xy, B as 3, 6 and C as minus 3, 4. We are given that A is equidistant from B and C. That means AB should be equal to AC. Now AB is the distance between A and B. So by distance formula we can see that it is x minus 3 square plus y minus 6 square. And AC, when we apply the distance formula, x minus 3 means x plus 3 square plus y minus 4 square. Now if we want to simplify this, we can square both sides. So squaring both sides, the square root will go away, square root and square cancel with each other, or we can say just square root when squared, it gives this expression simply. So x minus 3 square plus y minus 6 square. This is equal to x plus 3 square plus y minus 4 square. So which formula we will apply here? A minus b whole square. A square plus b square minus 2ab. A square plus b square minus 2ab again. Here also a plus b whole square. So x square plus 3 square is 9 plus 2ab will give us 6x. Y square plus 4 square is 16 minus 2ab is 8y. So children, we have got x square on this side and x square on this side. When we'll subtract x square from both sides, they get cancelled. Same with y square, it also gets cancelled. Let us simplify this by taking like terms together, or we can take all the terms to the right hand side. So we get 0 is equal to 9 plus 6x plus 16 minus 8y minus 9 plus 6x minus 36 plus 12y. Let us keep the like terms together, 6x plus 6x. Now let us keep the terms with y together, minus 8y plus 12y. Now the constants together. So we have 9 plus 16 minus 9 minus 36. Now the like terms will get added together, so we get 12x. Here 12 minus 8, that is we get 4y. Here 9 and minus 9 becomes 0. 16 minus 36 we get minus 20. So this is a equation in two variables x and y. We can further simplify it. We can see that they have a common factor 4. So we get this 4 when comes to this side, 0.4, it becomes 0 only. So we get 3x plus y minus 5 is equal to 0. So children, given the distance formula, we know the distance formula, and given the condition that this point, unknown point, is equidistant from these 2 points, we have got this condition in x and y, or this equation in x and y. Now children, there is an assignment question for you. Check whether the points 5 minus 2, 6, 4 and 7 minus 2, they are vertices of an isosceles triangle. Children, do you remember what is an isosceles triangle? A triangle whose 2 sides are equal. So if we prove that any 2 distances between these 3 points are equal, They will certainly form the vertices of an isosceles triangle. Children, look at this example. Suppose a telephone company wants to position a relay tower at P between A and B in such a way that the distance of the tower from B is twice its distance from A. So we can say that if P lies on AB, it will divide AB in the ratio of 1:2. If we know the coordinates of A and B, can we find the coordinates of this point P? Let us do it first for a general case. Consider any two points A, x1, y1 and B, x2, y2. Assume that point P, xy divides AB internally in the ratio of m1:m2. That is P upon PB is equal to m1 upon m2. Draw AR, PS and BT perpendicular to the x-axis. Draw AQ and PC parallel to the x-axis. Then by AA similarity criterion, we know that triangle PAQ will be similar to triangle BPC. And we know that, children, when two triangles are similar, their corresponding sides are in equal ratio. So we get PA upon BP is equal to AQ upon PC is equal to PQ upon BC. Now let us first try to find the length of AQ. Clearly AQ is equal to RS because they are opposite sides of a rectangle, and RS is equal to OS minus OR. What were the coordinates of point P? The x coordinate was x, and the coordinate of A, its x coordinate was x1. So we can say that OX is equal to x and OR is equal to x1. So AQ or RS will be equal to x minus x1. Similarly, PC will be equal to ST, which is equal to OT minus OS, that is x2 minus x. PQ will be equal to PS minus QS, that is PS minus AR, which is equal to y minus y1. BC is equal to BT minus CT or BT minus PS, which is equal to y2 minus y. So when we substitute the values in the statement number 1, we get m1 upon m2, that is the ratio in which P divides A and B, is equal to x minus x1 upon x2 minus x is equal to y minus y1 upon y2 minus y. So m1 upon m2 is equal to x minus x1 upon x2 minus x. So we get x is equal to m1 x2 plus m2 x1 upon m1 plus m2. Similarly, m1 upon m2 is equal to y minus y1 upon y2 minus y. So we get y is equal to m1 y2 plus m2 y1 upon m1 plus m2. So we have got the coordinates of the point P xy, which divides AP in the ratio of m1:m2, and all these coordinates are in terms of the coordinates of A and B and the ratio in which the P point is dividing AB. So what are the coordinates? m1 x2 plus m2 x1 upon m1 plus m2 and m1 y2 plus m2 y1 upon m1 plus m2. And children, this formula is known as section formula. This can also be derived by drawing perpendiculars from A, P and B on the y-axis. Suppose we take the ratio in which P divides AB as k is to 1, then the coordinates will be kx2 plus x1 upon k plus 1, ky2 plus y1 upon k plus 1. Children, we use this formula to find the ratio in which a point divides a given line segment while doing questions. Now there is a special case. Suppose we want to find the coordinates of the midpoint of a line segment. The midpoint will certainly divide the line segment in the ratio of 1:1 because both the parts are equal. So when we put the value of m1 and m2 both as 1, we get the coordinate of the midpoint as 1 into x1 plus 1 into x2 upon 1 plus 1, 1 into y1 plus 1 into y2 upon 1 plus 1. That is x1 plus x2 upon 2 and y1 plus y2 upon 2. Now children, let us do a few questions based on this formula. Find the coordinates of the point which divides the join of -1, 7 and 4, -3 in the ratio of 2:3. So there are 2 points, -1, 7. Let me name the 2 points as A and the other point as B. There is a point which is dividing this join, that is the join of A and B, in the ratio of 2:3. We want to know the coordinates of this point. Let me suppose that the coordinates are x:y. We have just done the section formula which tells us the coordinates of a point which divides a given line segment having their coordinates in a ratio of m1:m2. So if I compare, I can write that A, which is having -1, 7 as the coordinates, its coordinates can be also be generalized as x1, y1. B, 4 minus 3, they can be compared with x2, y2. And m1:m2 can be compared with 2:3. Now I want to find the coordinates of P, that is x and y. So x is equal to m1x2 plus m2x1 upon m1 plus m2. Let us put the values. m1 is 2, x2 is 4, m2 is 3, x1 is -1. m1 plus m2, it is 2 plus 3. So we get 8 plus -3 upon 5, 8 minus 3 upon 5, 5 upon 5 is equal to 1. Let us find the other coordinate again. m1 y2 plus m2 y1 upon m1 plus m2. So we get m1 is 2, y2 we get -3 plus m2 is 3, y1 we have 7 upon 2 plus 3. So -6 plus 21 upon 5. 21 minus 6 is 15 upon 5 is equal to 3. So we have got x is equal to 1 and y is equal to 3. So the coordinates of P, the point which is dividing the line segment or the join of A and B in the ratio of 2:3 are 1 and 3. Children, I am going to give you a question for homework. Find the coordinates of the points of trisection of the line segment joining 4 minus 1 and -2 minus 3. Children, when we say trisection, means the line segment is being divided into 3 parts. So I am going to give you a hint. The first point, say you can take it as P, it will divide AB in the ratio of 1:2. And the second point Q, it is dividing AB in the ratio of 2:1. So one by one you will apply the section formula and find the coordinates of P and Q. So children, this was part 1 of chapter number 7, coordinate geometry. I hope you have understood what we have studied today and realized the importance of coordinates in our real life. See you in part 2. Keep practicing, keep progressing. Thank you and have a nice day.